So in the project I'm working on, we started using an external API, and all the data we got from that external API was ultimately for the user, so the person making the request. Now, since it is an external API, that means we do not have full flexibility or control over the underlying query. So for example, if you want to have attribute-based access control, usually in your repository service or whatever you're using, sets the filters in the query itself, and well, that way you ensure that you're not exposing any data that doesn't actually belong to that specific user. However, again, since it's an external API and we do not have full control over it, that meant we needed to first query the data with whatever filters were available to us, which were limited, and then at the runtime filter out those that didn't pertain to the user. But the problem is we have a lot of services, and they usually don't communicate via the same data access layer. Now, the plus is we're working with a monorepo, so I was thinking, what can we do to ensure ABAC across any consumer? And then that's when I thought, hey, we're exposing schemas in this monorepo. Every single service consumes that schema, so wouldn't it be nice to have this policy in the schema itself, so it is all centralized within one entity? That way, well, we wouldn't need to worry about what functions to call or how do we construct and ensure this ABAC policy. Everything was in the schema. All we needed to do is parse the data with the schema and call it a day. And in fact, that is what Effect Schema shines at. So what did I do for this? Well, I created a context. All services need this context. So we have the ID and the email of a user. So this can be a session context, a request context, whatever you want it to be. And this one is completely dynamic. So if you come from Effect, that's why I'm not using effect.service. I'm using context.tag. And with this, if I come here, I have the schema. So let's say we have a project schema. We have the ID, name, description, and finally metadata. Now this metadata can be a JSON. So as you can see, this can extend beyond a restricted API. Let's say since this is a JSON property, it's unfeasible for your query engine to deserialize. Maybe you have versioning for the metadata or context dependent metadata. So obviously that's not something you can have in your query engine. So you need to handle this at the runtime. So that's why I'm using JSON to further showcase how we can solve this. And so basically this is, well, this structure. It has visibility, so either public or private, and then it has an owner team ID. So what's the idea behind this? Well, if it is public, anyone can access it. If it is private, only the owner can access it. So with this, I added a filter effect. We get the data here, so as you can see, visibility and owner sim ID. And then I pipe through the session, get the session here, and then we check if it is public or, well, the session.id is equal to the data.owner sim ID. We return true because it should be visible. Otherwise, we just return a parse result.forbidden and then simply say access denied. That's it. And now with this, we have our project and it has the metadata here. But well, you validate against multiple projects. So you have an array of projects. So let's suppose we have a response. So response is equal to schema.struct, and then we have projects, which is an array of project. Now, currently, this wouldn't work as you would expect it to. This is not ABAC. You're basically failing the whole structure if we get a forbidden. But what we can do here is use a utility I mentioned in another video. And that is the correct way of validating against arrays in such way that if the coding a specific project fails for some reason, maybe the data is incorrect or we get an error of this kind, we fall back to null for that entry and then we filter out the null values. So basically a non-null or nullable array from fallible, and we get the three generics, so decoded, encoded, and the context, and then we get the schema. And here what we do is say schema dot transform and we say schema.array, and the schema we pass in, and then we say to what, and this is actually null or, and then we say to an array of just the schema. And with this, we get the decode and encode. So here we can add some annotations, and we can say decoding fallback, and then we can say effect.succeed with null. Now here you would add logging. I'll show you in a moment how I recommend doing that. But anyway, we say decode, we get the decoded here, and then decoded.filter where predicate is not null. And for encode, it's just identity, because well, we accept an array of null or a, so that makes sense. Or should I say null or I, because it is the encoded part, and function comes from effect. So we return what we take in, and then strict true. So nothing too fancy. And then here we can say this instead. That way, when we get a forbidden error or the structure is in a different format, what we do is fall back to null. And then we apply a transformation that is going to filter out those invalid items. And as you can see, what we get back is, and let's do decode sync and then response and then pass in something. As you can see, it is just an array of non-nullable items. And with this, no matter the consumer, all you need to do is use a utility like this, and it is going to automatically filter out the data based on this condition. But this isn't that useful. And why? I mean, this works. If you were to test this out, it would work, because well, this is going to ensure that it is going to remove that invalid item. But let's say metadata is a property that is very volatile. It is an unsafe property. That means that perhaps your external API or even your own database cannot ensure the integrity of metadata. And it is not entirely necessary. What I mean by this is you can have a project without metadata. After all, that's why it is metadata. So instead of failing the whole entity, if metadata comes with a different structure, what you can do is add a fallback here, right? So you can say annotations, decoding fallback, and then effect.succeed with null. As simple as that. And well, you need to say null or, so it works. But there's a huge problem. You are allowing this project entity to exist because you are decoding from an error here. If you get a forbidden, this forbidden actually doesn't represent anything beyond simply stating that metadata is not meant for the user. So in Effect Schema, how can you ensure this error propagation in a way that you decode back from any other type of error that is not of type forbidden? Because if it is a forbidden, you want to hide the entity in its entirety. Meanwhile, if it's a validation error, you want to set metadata as null. So how can you do that? Well, for that, you can come here and add a body. So you can say issues or well issue, and then you can say issues is equal to array formatter, and this comes from Effect Schema. And then you can say format issue sync, and then you pass in the issue here. And this is going to give you an array of issues, basically. So as you can see, you get the tags here, the path, and then the message. So here you can say if issues.sum issue.tag is equal to forbidden, then you want to propagate the issue. Otherwise, you can fall back with null. So succeed with null, and then here fail with issue. And that's it. Now, why an array of issues? Well, that's because you can have parallel issues. So you can have an issue from a filter, but also from a missing property, for example. So that's why you get an array back. Though you can change that behavior in the decoding strategy. So if you say this and then you can say errors, first, all, or undefined. Anyway, with this, you can now ensure that if you fail with a forbidden, it is going to be propagated over to this right here, and it is going to filter out the entity in its entirety. Meanwhile, if it fails with whatever other issue, metadata is going to be null. And this is how you can achieve ABAC with Effect Schema. And as you can see, this library is way more powerful than any other validation library. And I say this because which validation library allows you to have context. So notice how this schema is going to require session. So when you're decoding it, you need to provide the session. This in itself is a very powerful feature. And on top of that, you get great composability. So you can create all of these type of helpers with this. There's no need to create high order functions that wrap the schemas, decode internally, nothing. Everything is composable out of the box. Now, before closing off the video, I always suggest logging warnings if you create utilities like this, because if you have very complex schemas, it is not that easy to trace back or see why an item in particular was filtered. So for that, what I would do is use the effect logging system, because you perhaps have it hooked up with a file or who knows what. So I would say zip write, and then we can say log warning, and then we can say non-nullable array from fallible, and then we can say schema AST, and we import this from effect, and then we can say get title annotation, or you can say identifier annotation. Well, you can compose this with different types of annotations with different priorities. I'm not sure if out of the box it has something like that. Doesn't seem like so. So I'll just say get identifier annotation for what? For the AST of this schema, and this returns an option. So you can say or else, and this also comes from effect. So we can say or else, and then we can say item, and we're getting an error here because we should do get or else, and we can say filtered, and then we can say array formatter, format issue sync, and then we get access to the issue here. And then, well, you can map over this where we get each issue, and then we can access the message and then join this. And then finally, we can succeed with null. Now, if you're not familiar with zip write, it is basically execute these two effects, so the log warning and the succeed, in a sequential manner, but ignore the result of the left effect. So we basically keep the null, and that's it. Obviously here I would recommend having like a priority, so first identifier, then if it doesn't exist, get the title, etc. And well, you can also perhaps format the issues better, but the key point is having somewhere where you can view why a certain item was filtered. So with this, in the message of the issue, you can say project does not belong to user, or something along these lines. And now you know, if something goes wrong, you can easily check your logs and see what went wrong. Anyway, this wraps up the video. If you want to see more content like this, make sure to subscribe. I'll see you in the next one. See ya.